Based on that, I have prepared one program. So are you aware about Kill programming? Kill microvision?
Yes, sir.
Yes, sir.
Okay. So when we start the Kill microvision, in that file edit, some menus are there. After that, you go for project, new project, and select your controller. Okay. And after selection of controller, this blank window is there, gray color. After that, you have to select new file. Okay. And this is related to your text file. So initially, while using the project and its name, it is not necessary to give the uh, type of extension, that is either assembly or either in C language. So in this case, in writing the name of project, or we simply go with the known. Okay, so here name only mention, so extension is not required. And when we start related to text file, either from this or file new file, so this is my file. So in that case, you have to give the extension. Suppose I have mentioned that and.asm. So .asm is an extension for assembly language programming, and in that just name is given. So in that I have write the first instruction, that is org starting memory location move data transfer instruction. So here I have mentioned 0f5h contents belongs to the A, that is accumulator. Actually contents are F5. If we not use here 0, then it will show the error. Okay, error at second line. So we cannot write directly the hex value, that is from A, B, C, D up to F. So in that case, you have to use 0 before that. So it will not consider the 3 digits, only consider the 2 digit F5. Okay. After that, second register, that is B, suppose 09 is there, and I have to perform the multiplication operation. Who else are there? Omkar Nag Shetty. Okay. So screen is visible to you, na? Hello?
Yes, sir.
Okay. So kill screen is visible or now showing on the screen. So in that, if we consider the two operands A and B for the multiplication, and intentionally I have taken the result is greater than 8 bit. Okay, whatever the multiplication is there. So after this, we will start execution, debug. Okay. So initial content, whether it is seen to you R0, R1, R2, R7, and then SFRs, A, B, stack pointer, and maximum position of stack pointer, program counter, and states. And after that, PSW register is there. So initially it is 00. When some operation is performed after the storing result in accumulator, that is execution of an instruction, the content of PSW may change. We will see. So we will go step by step execution. First, content of accumulator. Here I have mentioned H. So F5H belongs to A register. Initially it was 00. After that B 09EH. So it will not show EH, as default value is hexadecimal value for this. Okay. And after that we have to perform multiplication. So see, before result, content of B are 09 and A are F5. So see, these are the contents. So 9DH is A register's content and B register is 08H. So 08 is your MSB and 9D is your LSB. So lower byte is 9D and higher byte is 08. So combine is 089DH. This is the result of multiplication. And at the same time, see here, parity flag is set. If you have seen the number of ones available, so based on that parity is set. Again, overflow, that is, sorry, overflow is also occurred. that is carry is generated, that is result is greater than 8 bit, and here carry auxiliary carry is not generated, and remaining RS is not again used here. So this is related to multiplication. If you change the content to the division div, we will see. Let's save this, recopy it, and then run. Okay, first A divided by B, second content, and after that result. So remainder whatever is loaded in B register and quotient will be loaded at A register. So here we are not using the stack operation. So stack pointer is at top level, that is 07. So it will not change. According to that, if it is happen, some contents are also changed. So this is related to various operations. Someone is here. Avinash Pawar. Okay. So after this, we will see the next, that is logical instructions. Okay. So similar to the arithmetic instructions, if we want to perform some logical operations on the contents or operands, source operand and destination operand, in that case, we will use the various logical instructions like AND. For AND, ANL instruction is used. For OR, ORL. For XOR, XRL. And after that, we see the clear, complement, rotate left through carry, and here only rotate left, that is without carry, rotate right through carry, and swap the contents. Okay, that is nibble wise swapping. So in this case, if we consider the instruction which are used for performing, suppose AND operation, and symbol is ANL. So here similar to the arithmetic operation, destination operand most of the times accumulator, and some cases we will use the direct memory locations, not like to this on the arithmetic always an accumulator. So some case, most of the times we use accumulator, but some cases that like direct, in that case we will go for the direct, and direct related to some cases port are also there. Okay, so we will see as per the applications, but see, when we consider the source operand and destination operand, pattern is same. Mnemonic, destination operand and source operand. When we consider the immediate value, hash symbol should be there. So after hash, whatever contents are there, it will be considered as a immediate value. And these numbers or value, digits, whatever. So they are simply ANDed with the content of accumulator, and result is stored in accumulator always. Okay, so after that, this is related to immediate value. After that, register to register, that is register addressing. Accumulator is one of the operand, and another operand is also register from R0 to R7. Whatever the operation is there, here we consider the AND. A ANDed with RN, and result is stored in A. After that, direct, either memory or related to the port operations are also there for toggling the bits of the ports 0, 1, 2, or 3, whatever. So related to that, so direct operation, again result is stored at the accumulator. And related to the indirect operation, that is RI, I means 0 or 1, that is R0 or R1, only two registers are capable to perform this type of operation, that is at the rate. So A comma at the rate RI. And after that, if we perform the operations with direct value, or that is direct in the sense of port, and if we consider the memory operation, so in that case contents of that memory with the accumulator content, and result is loaded at the direct. Okay, so when we consider these two conditions, mostly here we use port, that is for getting the data on port after satisfying or checking some conditions as output port. So according to that, further devices may operate. So here mostly consider the direct means. When we consider the destination, direct is a destination. In that case, mostly consider the port, that is port 0, 1, 2 or 3, any port. Okay. So number of bytes as per requirement. We need not to worry about this as initial state. We cannot go further or beyond the 4K. Okay. So if we consider the AND, similar operation is related to the OR. So functional difference is, instead of ANDing the content, here ORing the content between first operand or source operand and destination operand. So similar to that again, XOR. Okay, XOR. So same conditions are there for these three instructions, AND, OR and XOR. So operation is different. So whatever results are generated, they are different. Okay. After that, we go for CLR. CLR means clear. So if we mention CLR, suppose A register, in that case, accumulator will be cleared, that is loaded with 00. If we consider CLR C, here carry flag is cleared. Here single bit, but applicable for carry also. CLR C is also applicable, not only for the 8-bit registers. After that, if we want to complement the content, that is whatever content D0 to D7 position, if you want to complement, in that case you simply use the instruction CPL A. So A is nothing but A bar, as you have seen in digital techniques. A is nothing but A bar. Okay, so in that case complement operation is performed, only single operand is there on which we want to complement or performing the complement operation. After that, next is related to the rotate operations, either rotate left, rotate right, and that through carry or without carry. So if we consider first case, that is rotate left without carry, so we should mention only RL, and here only one operand, that is A, that is RL A. So in this case, the contents of accumulator are shifted in left direction by one position or one bit. So here carry flag does not affect on the operations. Whatever the position of carry is there, either 0 or 1, it will not affect on the contents of accumulator in case of RL instruction only. And if we consider the RLC, that C stands for here carry, in that case rotate left through carry will be happen, that is operation will be performed like whatever the contents allocated in A register will be shifted by one bit through the carry flag towards left. We will see in this case, suppose move A comma hash 2 4, simply we say 20H. Okay, so in this way consider A is equal to 2 means 0 0 1 0 and 0 1 2 3 4. So these are the 8 bits associated with the accumulator. Is it visible?
Yes, sir, it is visible.
Okay, so after RL A, when we perform rotate left, in this case the content of accumulator R A is equal to एक पोजीशन लेफ्ट ला शिफ्ट करायचं. So here this is your first bit. Allocation is not done. Okay, make border like this. Okay, so this bit will be shifted in left, that is in reverse direction. So we will consider copy the content here. So whatever digits are there, it will be shifted like this. So we need to, okay. So this content shifted in leftward direction. So here after these two digits, 1 is there. So here only after 1 0. So position is shifted by 1, or simply we consider it like D7, D6, D5, D4, D3, D2, D1, D0. Okay, see. So in this case, initially this condition is happen, that is 0 0 1 all zeros. Okay. After that, this 0 is shifted in this direction, that is shift, okay, shifting of this bit towards left hand side, shifting of this bit by 1 position in left hand side. So we consider that this 0, like this 0 is shifted here, 0, and next 1, 0 0 0 0, and this 0 is coming here. So when we consider this like this, okay, if we consider before execution and after execution, okay, so after execution this 0 moving in this position, that is D0, and 1 1 position is shifted, so it will becomes whatever the number is there, 4-bit combination like 4 and then 0, 40 H is your combination related to this, and then we will mark with the some different. So here, are you getting? Hello?
Yes, sir.
Rotate left. Okay. After that, we move towards the rotate left through carry. We use this instruction instead of only RL, we go with RLC. Rotate left through carry. Okay. So we will simply take these numbers. It is here. One thing is C or CY carry flag we will mention, and if initially it is, we consider one set. So before and after we will analyze the contents. Before it is like this, okay, 20H before. After that we will see writing this. Cannot make like, okay. So rotate left now. So in this case, same operation is there. So this 0 is copied to carry flag. And whatever the contents, earlier it was 1. So it will moving towards 1. Or simply we consider, sorry, here 1. Earlier we considered as 1. And after that it becomes 0. And this one transferred to here, next 0, 0, 0, 0, 0, 1, 0. Okay. What will be the combination? Again, this becomes 4, this becomes 1. So 41H is your value after first rotate. Okay. Are you clear? Through carry.
Yes, sir.
Okay. This 0 is shifted to the carry flag, and carry flag's content, this 1 is shifted here. In this way, all the bits are shifted by one position towards left side, and then last or MSB bit is shifted in the carry flag position or carry flag status. So if it is earlier 1 and if this bit is 0, then it becomes 0. If this bit is 1, then in that case this bit also remains 1, but earlier content is shifted here. So that's why we take a cross. That is, if it is 0, we consider carry is 1. So here the content becomes 41H. So after execution, okay. So after execution, these contents, and similar operation is performed for rotate right also. So in case of rotate right, RR, rotate right, whatever the contents are there, they are simply shifted by one position towards right hand side. So in this case, shifting these contents, the contents becomes, so see, this position content,
0 1 hex answer येतं त्याचं
yes,
1 0
1 minute, no, okay. So in case right shifting, so shift here first 0 0 0 0, sorry, 1 na, 0 0 0, this is becomes and colored. So what will be the combination?
1 0 hex
1 0 x 1 0 x. The remaining candidates, are you able to understood? Hello?
yes sir
Okay. रिस्पॉन्स काहीच देत नाही, ते एक दोन कॅन्डिडेट असतात. हा, मग थ्रू कॅरी कन्सिडर करूया सेम. इनिशियल पोझिशन of carry is we consider as 1. सांगा आता इथं काय RRC सेम कंटेंट
1 1 hex
तुम्हाला अगोदर डिलीट करावं लागेल, हे परत कलर प्लेस होईल, इथं होईल कलर. Other than Prajakta, from voice side, are you listening? Satyajit. Hello? Satyajit.
हाँ सर.
काय ते आन्सर?
काय माहिती नाही सर.
समोर काय चाललंय? रोटेट लेफ्ट ना? हॅलो?
हा
रोटेट लेफ्ट ऑपरेशन चालू आहे ना?
हा
थ्रू कॅरी, विदाउट कॅरी?
हा हा
हा हा काय ऑपरेशन चालू आहे?
थ्रू कॅरी चालू आहे सर.
लेफ्ट रोटेशन, राईट?
हम्म.
कसं काय हा म्हणते? रोटेट राईट चालू आहे. तुम्ही नाहीये स्क्रीन कडे बघा. रोटेट राईट चालू आहे इथं बघा. RR सांगितलंय मी. एक परफॉर्म झालंय ऑपरेशन, दुसरं करायला सांगितलं. तुम्ही म्हणता रोटेट लेफ्ट चालू आहे, तर यस चालू आहे. कसं करायचं? व्हॉट विल बी द आन्सर? उत्कर्ष चव्हाण, आर यू लिसनिंग? चव्हाण उत्कर्ष,
हा सर.
काय येतं आन्सर?
1 1 hex
1 1 हेक्स. कॅरीचं स्टेटस काय होतंय? कॅरी 1 आहे, 0 आहे, आफ्टर एक्झिक्युशन
0
0. नक्की ना? ओके.
हा
कॅरी 0, काय येतंय? 1. Okay, so this becomes 1 1 x. Okay, clear है? RR आणि RRC. Okay, after that we go for next.
सो 1 1 येतंय का 0 9 0 येतंय?
1 minute.
कारण कॅरी पण इकडे राईटला शिफ्ट.
ओके ओके, सॉरी. हाँ, कॅरी शिफ्टच होणार आहे ना इकडं. हे कंडिशन इनिशियल. हा इथं गेला. कॅरी फिरून इकडेच येणार. बरोबर आहे, सॉरी. तुम्ही सांगितलं, मी म्हटलं क्लिअर आहे, मी पण नाही जास्त राईट शिफ्ट करायचं, एक एकने शिफ्ट करायचं. चला, दिस 0 right here 0, then next 0 0 1, 4 zeros here 0, and this one will be at this position, so 9 0. Okay, this one moving in rightward direction, so repeat. So after D0 it will moving towards the D7. D7 to D6 ला जायचं आहे. So 0 here 0 0 0 क्रॉस करायचं 1. हे परत इथं येईल. Okay, so 9 0 is your answer for the RRA operation. After that you should simply make complement, that is CPL of A. What will be the answer? CPL of A, CPL
09 hex.
no, not 09. Here it becomes 0 1 1 0.
6FH, sir.
6F 6FH. Who is this? Thank you. Hello, who has given answer?
Nikhil Bhosle.
Nikhil. Thank you Nikhil. Okay, so 6FH is your complemented answer. Again, if we want to perform some operation, not required, complete. Okay. And CLR is not required to be performed. So whenever we use the CLR A, the content of accumulator are 00H. So these are the operations performed on the source and destination operands as a logical operations, or we require, or we will perform logical operations. After that we see next bit oriented operations or bit oriented instructions. So here we consider the Boolean or bit manipulations, that is the instructions which are used to perform the operation. Who is this making some noise? Abhishek. After half an hour. Someone else? No. So here, when we want to perform an operation on a single bit, here bit is important, single bit. In that case, we will go with these instructions, that is bit manipulation instructions. So here, mostly if you want to clear some contents from a single bit or single pin, in that case we will go with the bit manipulation instructions. Suppose if we want to clear the carry flag when we want, or if you want to perform an 16-bit addition or addition with carry, in that case initially you have to clear the carry, whether it is set or not we don't know. So before using the add C, it is necessary to clear C. So before add C, you have to perform CLR C. So carry, if it is set, it will be resetted. If it is already resetted, no problem, it remains in resetted state. So CLR C. And in case of bit here, bit from any port, suppose P0.2, CLR P0.2. In that case, that particular bit is cleared. Or in case of set the bit, set P1.5. So here setting, clearing, ending. Okay, whatever the condition is there, for these condition, bit operation. So which registers are applicable or suitable for these kind of operations, that is when we consider that a particular port acts as a IO port. In that case, if we consider bit manipulation, that is if we are single bit from that register is accessible, or we simply say that the bit addressable register. So bit addressable register. Okay. So if we consider the bit addressable register, so these are the registers generally used when when we want to use particular pin from that bit, from that register, that is P1.5 or P0 point something, P0.4, whatever. So if we want to use a particular pin from that register, here we consider port as a 8-bit register. In that case, we consider as a bit addressable register. But if we consider A, we consider B, if we consider and yes, buff. Okay. So these registers are not bit addressable registers. These are used as a complete bit, that is A complete, B complete, S buff complete. Okay. But in case of this P1, P0, Pcon, SCON, IE, IP. Okay. These are the bit addressable registers. So from that, we are able to access any one bit, like suppose Pcon 0.1 or 2, whatever, SCON 0.1 to I, like that. So in this case, we are able to access a particular bit without affecting the other bit. So in this case, we will consider these type of registers are bit addressable registers, and bit manipulating operations are performed on these registers only. Are you clear? So when we discuss related to the bit manipulation or Boolean instructions, okay. So in this case, if you see, C, that is carry, is nothing but single bit, either set or reset, 0 or 1. And when we consider the bit is nothing but either P1.1, P2.3, P0.7, like this, or the bits from any bit addressable register. Either you want to clear, either you want to set or complement. Okay. So in this case, CPL bit, that is CPL P1.1, port pin is complemented P1.1. If it is already set, it will resetted. If it is already resetted, it will be set. Same is related to some AND operation on particular bit or and carry flag. So in this case, AND operation is performed on, again, a single bit. We cannot say registers. So single bit from bit addressable registers. So this is related to the content shifting or content modifying. So again, one more is, move. So if you see the move instruction, so it is not here, it is not used for copy or load the 8-bit content. So here simple bit content, either 1 or 0, will be copied to carry flag, or reverse. The carry flag status will be copied to bit, either P1.1 or P0.2, like this. So moving the content here in a single bit, only single bit, that is either 0 or 1, will be shifted to the destination bit only. C is also bit, not an register. After that, jump on carry, okay, related operation, that is single bit. Here C is your single bit. Jump on not carry, carry set असेल तर JC, आपल्या काही कंडिशन पाहिजे, रिलेटिव्ह ऍड्रेस असेल. कॅरी सेट नसताना जंप करायचंय तर JNC वापरायचंय. Similar to carry, instead of that if you see the beat is nothing but the position or status of particular port P1.1 suppose. So JB here P1.1 relative address up. जर बीट सेट असेल तर अप जायचंय, बीट रिसेट असेल तर नेक्स्ट इन्स्ट्रक्शन. सिमिलर टू JNB जम्प ऑन नॉट बीट, बीट सेट नसेल तर जम्प करायचं. हिअर REL मीन्स रिलेटिव्ह ऍड्रेस और लेबल. ओके, and after that JBC jump on beat, okay, with carry or through carry. So all these operations related to the beats, they are considered as a beat manipulation instructions. Okay, beat manipulation instructions. Okay, so in this case generally while testing the conditions whether carry is set, in that case you want to access some ISR subroutine or you want to change the status of port pin. In that case we prefer for bit manipulation instruction that is related to the only single bit operations or checking the status of single bit instead of checking the complete 8-bit or 16-bit registers. Okay, so these are related to bit instructions or bit manipulation instructions. After that, last part is program branching instructions. So in case of program branching instructions, here branching means shifting the PC, that is program counter, by an required or desired memory location, or shifting the program counter to the required or expected memory location as it is mentioned under the label. So if we consider, suppose first instruction a call, that is call instruction is there, and the call instruction is again divided into two types, a absolute call and L is long call. Okay, so in these two cases when we consider the jumping is within 2 kilobyte of the program memory, okay, in that case we go with the a call instruction, a call address whatever 30H or 100H like this. But if instruction need to jump or program counter need to jump within the 64 kilobyte of memory, as the maximum interfacing size with the 8051 is 64 kilobyte, 64 KB. In that case, we will use the L-call instruction. Both instruction function remains same, but only difference is the accessing memory size. That is when we consider the program memory or your code is less than 2 KB. In that case, you may use a call instruction, that is absolute, okay, call. But if your code size is greater than 2 kilobytes, in that case, you have to use the L call instruction, that is long call. Okay. After that, similar to these two, absolute jump and long jump. Okay. So same application is there. Instructions are only different. So here jump instruction is used. Yes, jump related to the short jump. Okay, within 2 kilobytes, and these two, A jump and L jump, both are related or having the same applications. And if we are having external memory, in that case you have to prefer the L jump instruction. And if we are using the internal program memory of 4 KB, then in that case you may use A jump instruction. But if we are using L jump, it is feasible to access the or reach to the maximum memory location, that is up to the 64 kilobytes. But here unnecessarily if you use L jump, then your byte size is increased. So if you want to reduce, then go for A jump. Okay, so mostly yes jump and L call related to the memory size up to the 2 kilobytes, and L jump is used for complete whatever the size is available with 8051, that is maximum is 64 kilobytes. So it will be applicable for 64 kilobyte. After these call, that is jump instructions, here another instruction is return and return from interrupt. So whenever we use a normal function like delay, subroutine delay. So after completion or after execution of that delay subroutine, you have to use the return instruction, that is RET. And if program counter is pointing towards the interrupt service routine, that is ISR, and after completion of ISR, that is complete execution of interrupt service routine, ISR, you have to mention the instruction RETI, return from interrupt, so that your program counter will move or shift towards the main program from which it is suspended or terminated, so that it will continue from that instruction. So return is for related to the normal operations or normal subroutine, and when we perform the operations related or based on the interrupts, in that case you have to use RETI, return from interrupt. Okay, after this jump, okay, so here jump to the memory locations pointed by DPTR plus accumulator. Here A is your offset value, as we have already seen in case of MOVC A comma @ A plus DPTR. Okay, so similar to that, if you want to simply jump the memory location pointed by DPTR along with the offset value by 2, 3, 4, or only by DPTR, in that case you should make A is equal to 0 before execution of this instruction, as we have already seen in case of addressing modes. Okay, so A plus DPTR points on the required memory location, so that your program counter will shift at that cumulative address. Suppose it is 200 and this is 10, then it will points to the 210. It is program counter points the 210 memory location. Okay, next is JZ and JNZ. Jump if 0, that is content of accumulator. So after performing some operation, mostly ALU operation, if result of an operation is 0, that is subtraction is there, in that case, or multiplication is there, in that case if it is 0, then jump, that is program counter will jump to the, here relative means your label, whatever label is mentioned, up, down, whatever. Okay, and opposite to that, jump on not 0, that is if result of ALU operation is not equal to 0, in that case jump to the relative means respective label where it is pointed, that is up, if it is mentioned up, and when up is mentioned above 4 or 5 instructions, then it will simply points the program counter to that label up, or it is, if it is down, or any name you have written, that is Ram, Sham, whatever. After this jump instructions, we will go for the comparison instructions, that is CJ and E, compare and jump if not equal. Here comparison between two operand, that is contents of two operand will be done, and based on that condition, here NE not equal if the contents belonging to operand 1 accumulator and another operand, if they are not in equal state or equal value, in that case it will jump to the relative address, that is program counter will jump to the relative address. This is used for testing or comparison purpose between the two sections or two numbers, that is number sorting, arranging the numbers. Here CJN is used, or some decrementing the numbers, we will use CJNE or DJNZ. So these are the comparative purpose instructions. So here CJN is compare and jump when it is not equal in the sense content of this direct and content of accumulator. If they are not equal, then it will jump. These are the combination, that is A hash data, RN hash data, @RI hash data. So contents are copied from any one of the operand to another operand. Okay, and here relative is the label which is mentioned to shift the locations or position of a program counter. And last thing related to this is DJ and Z. Okay, so here DJ and Z is nothing but decrement and jump if not 0, decrement and jump if not 0. So in this case, when we consider some contents related to suppose Rn, and for that purpose we have to perform the operation like decrement first and then jump where the memory locations or address pointed here rel, and if it is not 0, suppose we consider that next operation, that is b, j and j, r4 comma so clear. So in this case, any number, okay. If we consider R4 is your counter register, so that we have mentioned move R4 comma hash 05H. This is your earlier, okay, instruction or content belongs to that R4. And if we decrease, here which register is decreased? R4 by 1. So after this instruction or execution of this, R4 is nothing but 4H. Okay, and it will check whether it is 0 or non-zero. If it is non-zero, then go to up. Here I will mention up. So up is your label, so it will move again in upward direction, and again after execution, if this instruction is same, sorry, we will move in upward direction, and then we'll keep here itself, okay, or we simply write no operation, NOP. So again it will go to no operation, again it will decrement, and after this 4 becomes 3, it will becomes 3, and check whether it is 0 or non-zero. 3 is non-zero, so again it will go to up, no operation, again it will reaches to the 2, after that 1, and after that 0. When 0 condition is satisfied or happen, when it becomes 0, that is decrement, 1 चा काय झालं 0, and jump करायचे पण कधी नॉन-झिरो आहे का नाही, मग 0 आहे त्यामुळे परत हे अपला जायला पाहिजे का नाही, मग इथून बाहेर पडेल. इथं काय असेल सपोज रिटर्न काय करेल तुमच्या मेन प्रोग्रामला जिथं वरती असेल तिथं जाईल. क्लिअर आहे डीजे एंड जेड? हॅलो,
येस सर.
सीजे आणि आपण सीजे ने बघू. सीजे आणि सपोज ए कॉमा hash 02H. Okay, if we are considering this instruction CJNE, whatever the contents in earlier stage, it is A, suppose add A comma R3, असं काहीतरी instruction आहे. So after addition, if you want to compare the content with 0 to H, whether it becomes or equal to 0 to H or not, in that case, if compare and jump, if not equal, हे not equal नाहीये, सॉरी not equal आहे, इक्वल नाहीये, त्या केस मध्ये आपण काय म्हटलं इथं नेक्स्ट हे लेबल दिलंय. ओके, हे नेक्स्ट लेबल जिथं पुढे कुठे असेल तिथल्या इन्स्ट्रक्शनला इथं पॉइंट करायला जाईल प्रोग्राम काउंटर, आणि इथून पुढच्या इन्स्ट्रक्शन एक्झिक्यूट होतील. पण जर इक्वल असेल तर इथं नेक्स्टला जाणार नाहीये, ते इथंच काय नेक्स्ट इन्स्ट्रक्शन एक्झिक्यूट करत. सपोज इथं रिटर्न फ्रॉम दॅट सबरूटीन. सो इन दिस वे DJNZ and CJNE will work. Okay, so both are comparators, but application is different. Here one operand is used, here two operands, that is first one is suppose accumulator, second one is immediate value or some register. Instead of this we may consider that B register. So compare A and B. If not equal, go to jump. Jump on next. That is next. Whatever the instructions are there. If not, that is if it is equal, then return from that subroutine. Okay, main program la जाईल. Okay, so last instruction is NOP, no operation. Clear आहेत का instructions? Okay,
Yes,
so
sir.
here instructions are completed, we will see examples as per our example, that is program. We will see some program like addition, subtraction, division, and or like this. Okay, so these are the instruction. That is first, if we consider data transfer. Okay, here in this case, data only transferred, processing of data or modification of data is not done, and in most of the cases cases operand 1 and operand 2, so both operands are there. It may use one operand as a source and one operand as a destination, may be register or memory locations. Okay, if it is at the rate directly it is there. And here in case of accessing MOVC, accessing program memory, and that to the more than 8-bit program memory, that is A plus DPTR. Here MOVC, if you use C is in combination with the instruction that is move mnemonic, or C is in the mnemonic, not in the bit or operand state. So MOVC A comma at the rate A plus DPTR, but here A plus DPTR means your memory pointer, and content of that memory pointer will be copied to A. Similarly, when we use external memory, that is external memory is interface, in that case we will go for MOVX. X is for external, same operation to the internal program memory. Here only X is there for external program. Push pop operations are used for stack, writing content on stack by using push, and popping the contents or deleting the contents from the stack with the help of pop. Exchange either with the register and accumulator, okay, with same as it is 8-bit to 8-bit. And if you want to change only lower nibble of that respective two operands, that is A and at the rate RI, in that case we go for the EXCHD. Okay, after that next is arithmetic. So for arithmetic, mostly 4 conditions or 4 combinations are there: data, register, direct, and indirect. So based on that, all the arithmetic operations are work. But in case of multiplication division, only 2 registers are used, A and B register. Here comma is not specified between A and B, that is A comma B for multiplication. For division, A comma B, it is not there. You simply write MUL AB, DIV AB. While performing these 2 operations, the result of operation is stored. In case of multiplication, lower byte is stored at accumulator and higher byte is stored at B register, as earlier at the start of lecture we have discussed related to the operation. That is, we have done the program in that higher byte is stored in, that is 08 is stored in B register, and I think F or 1F whatever is loaded at A register. Okay, lower byte. And for division, quotient will be stored at A and remainder will be stored at B. Decrement, increment, and adjustment. After that, logical, for performing logical operations, AND or XOR, complement, clear, rotate operations. Okay, so A is important in most of the cases, ALU operations. And in case of Boolean or bit manipulations instructions, only single bit is used to perform some operation. Either in case of single bit, 2 possibilities are there, either 0 or 1, that is set or 0 is reset and 1 is set, that is reset or set. So here C is always accessed through these, that is bit manipulation. And if you want to access single bit from a port, mostly port P1, P2, P0, like that, so we will go with the bit manipulation. In case of program branching, here the jump and call instructions are used to shift the program counter at required or specific memory location as per the requirement. And whenever some conditions are satisfied at that time or need to be checked at that time, we will go for the JZ, JNZ, JC, JNC, or CJNE and DJNZ. So these are the instructions based on the some comparison. So in this case, comparison is done in case of CJNE between 2 operand. Okay, either one is direct immediate value and another one is register, or both registers are also there, A comma B, like this. It will jump to the relative address. And in case of DJNZ, one operand is used, and from that it is always decremented by 1 and then check whether it is becomes to 0 or not. And if it is 0, then it will not jump on the relative address. If it is 0, if it is 0, it will not jump, and if it is non-zero, it will jump to the relative memory address or locations, whatever the mention, with the help of label. That is, it is generally used, DJNZ is generally used for generation of some delay, or you consider that in most of the case when we want to generate and delay, DJNZ is used to generate and register delay, register based delay, and no operation. It will simply consumes your one machine cycle if it is required to add for the required delay.